All right. So these problems have to do with the exterior angle theorem. So we have a triangle PQR, right? And side PQ is extended through Q to point T. Which statement is not always true? Okay, well, we know that the exterior angle theorem says that angle TQR or RQT is equal to angle P plus angle R. It's equal to the two non-adjacent interior angles. So now let's see which one of these would agree with this. Is RQT greater than R? Well, it has to be, because if it's equal to the sum of two angles, then it has to be greater than either one of the two angles. So it's not that one. Is it greater than P? That's true also. It's equal to P plus R. So finally, is it greater than PQR? Well, not necessarily. It doesn't have to be, okay? It could be, but it doesn't have to be. Alright, so BCD is 6x plus 2. BAC is 3x plus 15. And ABC is 2x minus 1. So what's the value of x? We know that 6x plus 2 equals 3x plus 15 plus 2x minus 1. So 6x plus 2 equals 5x plus 14. So I'm going to subtract 5x from both sides, and at the same time I'm going to subtract 2 from both sides. So I get x equals 12. That's my answer, 12. Okay? 170. The diagram below of triangle ABC, side BC is extended through to point D. A is x, B is 2x plus 15, and ACD is 5x plus 5. So what is the measure of angle B? Well, we know that x plus 2x plus 15 equals 5x plus 5. 3x plus 15 equals 5x plus 5. I'm going to subtract 5x from both sides while at the same time subtracting 15 from both sides. So I get negative 2x equals negative 10 divided by negative 2. X is 5. But the measure of angle B is 2x plus 15. So that's 2 times 5 plus 15. That's 10 plus 15, so that is 25. Alright, so be careful. They didn't want x, they wanted b, so we just used x to find b. So b is choice 3. Okay, 70, 50. What is the measure of angle LKN? Let's call it x. We know that x equals 70 plus 50, so x equals 120 degrees. Choice 2. Which statement must be true? C is greater than D? No. ABC is less than D? No. ABC is greater than C? It's choice 3. Because angle ABC is equal to angle C plus angle D. So it must be greater than either one of those two, since it's equal to the sum of them. So it's choice 3. A is x squared minus 6x. B is 2x minus 3. And ACD is 9x plus 27. What is x? So we know 9x plus 27 equals x squared minus 6x plus 2x minus 3. So 9x plus 27 equals x squared minus 4x minus 3. I'm going to subtract 9x from both sides, and this is a quadratic, so I got to get one side to be 0. So I got 0 equals x squared minus 13x minus 30. Now I do my double bubble. X, x. So what factors of negative 30 will give me negative 13? Okay, well 15 and 2, and if the 15 is negative and the 2 is positive, that would work. Positive 2 times negative 15 is negative 30, and positive 2 plus negative 15 is negative 13. Split them up. X plus 2 equals 0, x minus 15 equals 0. Subtract 2 from both sides, x equals negative 2. Add 15 to both sides, x equals 15. Reject the negative answer, so x equals 15. Choice 4. Diagram below, D is on AB, AC, AD is this, BC is this. Find the length. So we want to know what the length of DB could be. Okay. Well, any two sides must be greater than the third side. So 7 plus 18 must be greater than 6 plus x. 7 plus 6 plus x must be greater than 18. And 18 plus 6 plus x must be greater than 7. So here we have 25 is greater than 6 plus x. Subtract 6. 19 is greater than x, or in other words, x is less than 19. Here we have 13 plus x is greater than 18. Subtract 13. X is greater than 5. And here we have 24 plus x is greater than 7. Subtract 24. So we have x is greater than negative 17. So based on this information, we don't have to put anything there. This doesn't help us because it already says it's got to be greater than 5. So saying that it's greater than negative 17 is already met by this requirement, that it's greater than 5. So it's got to be greater than 5 and less than 19. Well, that gets canceled, that and that, so our only choice is 2. Okay, we got everything's labeled here. Find QPT. So we want to find 6x plus 20. Well, we know 6x plus 20 is equal to x plus 40 plus 4x minus 5. 6x plus 20 equals 5x plus 35. I'm going to subtract 5x and subtract 20 from both sides. And we would get x equals 15. So the measure of angle QPT is 6x plus 20, which is 6 times 15 plus 20, which is 90 plus 20, which is 110. So, and that's degrees. Okay? We have a triangle, FGH. F is 42, and an exterior angle at H has a measure of 104. Okay, what is G? Well, we know that 104 equals 42 plus x, subtract 42. X is 62 degrees, choice 2. Okay. Which set of numbers represents the length of the sides of a triangle? So that would mean that 5 plus 18 must be greater than 13, and that works. 5 plus 13 must be greater than 18, and that does not work. So I'm going to the next one. 6 plus 17 must be greater than 22. That works. 6 plus 22 must be greater than 17. That works. Hold on. 23. Yeah, that works. And 17 plus 22 must be greater than 6. And that works. So it's choice 2. Let me just double check. 23 is greater than 22. 20. Yep, that one's it. Okay, let's see. We have a triangle. ABC. AB is 5. BC is 3. Which inequality represents all possible values for the length of AC in feet? So if we call it x, we know that 5 plus 3 must be greater than x. We know that 5 plus x must be greater than 3. And 3 plus x must be greater than 5. So 8 must be greater than x. Whoops. 8 must be greater than x, or in other words, x must be less than 8. If we subtract 5 from both sides here, x must be greater than negative 2. And if we subtract 3 from both sides here, x must be greater than 2. Well, if it's greater than 2, it's already greater than negative 2. So the two that matter are these two. So that means that 2 must be less than x must be less than 8. Which is choice 2. A is 95, B is 50, C is 35. Which expression correctly relates the lengths of the sides of this triangle? So this is large. How can we do that a better way? Let's see. We know that BC is greater than AC, which is greater than AB, right? Because of them being across from the different sides. So which one says that? Well, it says it in reverse, right? Or AB is less than AC is less than BC, which is fine. So which one is that? Choice 2. P, Q, R. PQ is 8, QR is 12, RP is 13. Which statement about the angles of PQR must be true? So we know angle Q is greater than angle P, which is greater than angle R. So which one says that? Choice 1. A, B, C. AB is 7, BC is 8, AC is 9. Which list has them in order from smallest to largest? So angle C, angle A, angle B. Choice 4. Alright, and let's just make a little thing here so we know what we're doing. Scalene triangle. A, B, C. B is 45. C is 55. So A must then be 55 and 45 is 100, so A must be 80. What is the order of the sides in length from longest to shortest? So longest would be BC. Next longest would be AB. And the next longest would be AC. So BC, AB, AC. Choice 4. In triangle RST, R is 58. S is 73. So then T would be 180 minus 58 minus 73. 49. Which inequality is true? So we know that RS is less than, because look, it has less than, so I'll do it that way, is less than ST, which is less than RT. So which one says that? RS, TS, RT. Right, this one. ST is the same thing as TS. Okay. Let's see, 24 and 18, I can find this angle over here, right? I can do 180 minus 24 minus 18, it's 138. Then I can do 180 minus 138 and get 42. Then I can do 180 minus 42 minus 66 to get 72. What is the longest side of triangle ABD? So it would be AB. Okay. Diagram below. A is 37, 117. Which side is the longest side? Well, we can do a lot of things here. We can do the fact that this angle plus this one is 180, so 180 minus 117. So this is 63. And then 180 minus 63 minus 37 to get this angle is 80. So which is the longest? AC is longest because it is opposite the largest angle. Now we're moving into side splitter theorem stuff. So CB is 3, CA is 10, which makes this 7, CE is 6, ET is what we want to know. So we can do 3 over 7 equals 6 over x, 3x equals 42, divide by 3, x equals 14. Choice 2. AT is 5, TB is 7, AV is 10. What is VC? So we'll call it x. So 5 over 7 equals 10 over x. 5x equals 70, divide by 5. X is, let me see, 14 again. Choice 3. AB is 10. AD is 8, so this is 2. AE is 12. Find EC, x. So 8 over 2 equals 12 over x. 8x equals 24. Divide by 8. X equals 3. Choice 3. We have a triangle. A, B, C. Alright, point D is on AB and point E is on BC. So this is D and E such that they're parallel. DB is 2, DA is 7, DE is 3. What is the length of AC? Interesting. Okay. So I would do this one as 2 over 3 equals, I would add these two and say 9 over x. So the little triangle's side over the little triangle's base is equal to the big triangle's side over the big triangle's base. And I would get 2x equals 27, and I would divide by 2 to get x is 13.5. Okay, I just want to try something else. I want to try 2 over 7 equals 3 over x. I would get 2x equals 21. And if I divide by 2, I would get x equals 10.5. So that's not the way to go. It's got to be done this way then. Okay? Okay, so 189 I need to go over again with you guys so you don't make that mistake. Write that down. 189. (190). AE is 3, ED is 6, DC is 15. Find the length of EB. So 3 over x equals 9 over 15. So 9x equals 45. Divide by 9. X is 5. Okay? So EB equals 5. So I could also do 190. Okay, let's see this one. AC is x minus 3. BE is 20. AB is 16. And AD is 2x plus 2. Find the length of AC. Alright. Well, 16 over 36 is equal to x minus 3 over 2x plus 2. So 36 times x minus 3 equals 16 times 2x plus 2. 36x minus 108 equals 32x plus 32. So I'm going to subtract 32x from both sides while adding 108 to both sides. 4x equals 140. Divide by 4. X equals goes 3 times 35. But we want AC is x minus 3, which is 35 minus 3, which is 32. Okay? CE is 25. AD is 18. DB is 12. We want to find this. So x over 25 equals 12 over 18. 18x equals 250. Think? No. 300? Yes. right? Because 3 sets of 425s is 300 because each set of 425s is 100. So that would be 300. Now I divide by 18, and x is 16 to the nearest 10th, so x is approximately 16.7 inches. Don't forget your label. Okay, let's keep going. Diagram below of ACT, D is the midpoint of AC. O is the midpoint of AT, G is the midpoint of... This is the a mid-segments theorem. So AC is 10, but since this is the midpoint, each one of these is 5. AT is 18, but since this is a midpoint, each one of these is 9. And CT is 22, but then each of these is 11. What is the perimeter of parallelogram CDOG? Well, the mid-segment is also equal to 1/2 the length of the side that it's parallel to. So this is equal to 11, which is half of 22. This one is equal to 9, which is half of 18, right? These two sides are parallel, so it's half of this side. And these two sides are parallel, so this is half of the length of this side, which is 5. So if I want the perimeter of, I want C to D to O to G. So I want 5, right, plus 11, plus 5, plus 11. So that's 32. Okay. Okay, D is the midpoint, E is the midpoint. So AC is, what is which expression represents DE? Well, DE is 1/2 of AC. So DE equals 1/2 of 4x plus 10. So DE equals 2x plus 5. The mid-segment theorem says that it's 1/2 of the side that it's parallel to. Okay, they're all midpoints. AB is 20. BC is 12. And AC is 16. What is the perimeter of ABEF? Okay, so I need this side, which is 10. I know this is 6, this is 6, this is 8, this is 8, this is 10, this is 10, this is 8, this is 6. I want ABEF. So A to B, wait, ABE to F. I want the perimeter of that. So 8 plus 10 plus 6 plus 20. 44. Choice 4. Okay. We got a mid-segment. Which statement is not true? Well, CE is 1/2 of CB. That's true. DE is 1/2 of AB. That's true. The area of triangle CDE is equal to 1/2 the area of triangle CAB. That's not true. The perimeter is equal to 1/2. The perimeter of this is equal to 1/2 the perimeter of this. That is true. So it's choice 3. The areas will not be in the same 1/2 ratio. 197. D is right here. E is here. F is here. Alright, what? If G is the midpoint of EF, let me label these. D, E, and F. Oop. If G is the midpoint of EF, so let me just draw my line for EF here. G is the midpoint, so if I'm going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 to the right, and 1, 2, 3, 4 down, instead I'll go 1, 2, 3, 4, 5 to the right, and 1, 2 down. So that is G. And H is the midpoint of DF. So apparently what we have here is a triangle. H is the, so I'm going over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 to the right and 2 up, so I'll go 6 to the right and 1 up. 1, 2, 3, 4, 5, 6, and 1 up. H, so this is a mid segment, right? It connects the midpoints of two sides. So these two sides are parallel. State the coordinates of G and H. So G is 3, 0, and H 2, -3. Label each point on your graph. Explain why GH is parallel to DE. In a triangle, a line connecting the midpoints of two sides is always parallel to the third side. You can also see they have the same slope of 1, 2, 3 over 1 of 3. And parallel lines have the same slope. Okay? In the diagram below, AB is 10, BC is 14, and AC is 16. Find the perimeter of the triangle formed by connecting the midpoints of the sides of ABC. So this would be 5, this would be 5, this would be 8, this would be 8, this would be 7, this would be 7, this would be 7, this would be 5, this would be 8. 5 plus 7 plus 8 is 20. I think, yes. DE is a mid-segment, so that means it's parallel. DE is 7, AB is 10, and BC is 13. Find the perimeter of triangle ABC. So this is 5 and this is 5 and this is 6.5 and 6.5. Find the perimeter of ABC. Well, the mid-segment is 1/2 the length of the far side, so we got 10 plus 13 plus 14 equals 37. The perimeter of the big triangle is 36. So that means we got 12, because it's equilateral, it says 12 and 12, which means we got 6, 6, 6, 6, 6, 6, 6, 6, 6. What is the length of EF? 6. Negative 7, 2. 3, negative 4. 5, 4. H, K, L. The midpoint is M. That looks like it's right here. Up 1 over 1, 2, 3, 4, 5, 6. Up 1 over 1, 2, 3, 4, 5, 6. This is M. And the midpoint of LK is N over 1 up 4 over 1 up 4. Determine and state the coordinates of points M is negative 1 comma 3. N is 4 comma 0. Okay, so how do we justify this? We do it the same way we did the other one. In a triangle, the line connecting the midpoints of two sides is always parallel to the third side, and therefore they have the same slope of, let's see, 1, 2, 3, 1, 2, 3, 4, 5 of 3, negative 3, 5, or 3 over negative 5. Right? 1, 2, 3, 1, 2, 3, 4, 5, 1, 2, 3, 1, 2, 3, 4, 5. Okay? .202 to 210 is about centroids, orthocenters, incenters, and circumcenters. Okay? So let me see if I could pull out the cards that deal with these real quick. I don't think it's that far in, actually. Oh. Okay, here we go. These cards 29 through 36. So cards 29 through 36 deal with this topic. Okay, so let's see if we can use the cards to figure this out. In which triangle do the three altitudes intersect outside the triangle? So I'm looking for the one that talks about altitudes. Oh, here we go. The point where all three altitudes intersect is called the orthocenter. The orthocenter may be inside or outside of a triangle. Look, when it's obtuse, the orthocenter is outside the triangle. So that would be when it's an obtuse triangle. Okay. 203. In a given triangle, the point of intersection of the three medians is the same as the point of intersection of the three altitudes. Which classification of the triangle is correct? Well, that's only going to happen with an equilateral triangle. Okay? For a triangle, which 2 points of concurrence could be located outside of the triangle? Well, we know we just talked about the orthocenter, right? So it's going to be either choice 4 or choice 2. Now let's look. Now we have an in-center, but that's always inside, so it's not in-center. Then we have a circumcenter. That's it. See, it can be inside or outside. The circumcenter. So circumcenter and orthocenter. In the diagram below, AE is congruent to BE. AF is congruent to CF, and CD, AF is congruent to CF, and CD is congruent to DB or BD. Point P must be the, well, look, the median is a segment joining any vertex to the midpoint of the opposite side. See how it's going from the vertex to the midpoint, breaking this half into two congruent parts? Same thing, vertex to midpoint, vertex to midpoint. So those are medians. The point where all three medians of a triangle intersect is called the centroid. Just like that. It almost looks like the same picture. See that? That's centroid. The diagram below shows the construction of the center of the circle circumscribed about triangle ABC. This construction represents how to find the intersection of, look, these lines are the perpendicular bisectors, right? If we connected, you see the construction lines? That's the construction for the perpendicular bisector, right? So three perpendicular bisectors, the perpendicular bisectors of the sides. Okay, and you can see that it's perpendicular to the sides. Really, it would be all four ways, like this even. Okay? In the diagram below of triangle ABC, CD is the bisector of angle BCA. So now we have angle bisectors, right? AE is the bisector of CAB. We have angle bisectors. And BG is drawn. Which statement must be true? Well, if these two are bisectors and they're meeting at point G, the only other line from here that's going to meet at that same point is the angle bisector of this angle. So that would mean that these two angles, DBG and EBG, would be congruent or equal. Uh-oh. Which geometric principle is used in the construction below? Look what we have. We have three angle bisectors. You see that? Three angle bisectors. So the intersection of the angle bisectors of a triangle is the center of the inscribed circle. Well, let's just find out about that. Let's go to angle bisectors. The point where all three angle bisectors of a triangle intersect is called the incenter. The incenter is in the center of an inscribed circle within the triangle. So doesn't that look the same? Okay, so it's choice 1. 209. The vertices of the triangle are plotted here. What are the coordinates of the centroid? Okay, the centroid goes from the point to the midpoint, from the point to the midpoint, and from the point to the midpoint. So, let's do that. And let's see where they cross. So what are the coordinates? This is 3, 3. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. Choice 3. Triangle has vertices 3, 3. Look at this. It's going to be the same problem. They actually gave you the same exact problem twice. 7, 9. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9. And 11, 3. This was 9, so 10, 11, 1, 2, 3. Is it the same? It is exactly the same problem. But in this one, they made us actually draw the triangle, but this is exactly the same problem. Determine the point of intersection of the medians and state its coordinates. Well, it's going to go to here from this side, right? And from this side, it's going to go to here. Ooh. What happened? Did I plot something wrong? 3, 3, 4, 5, 6, 7. 1, 2, 3, 4. Oh, I did. So I went 3, 4, 5, 6, 7. 4, 5, 6, 7, 8, 9. This point was good. This point was bad. 11, 3. This was 7, 8, 9, 10, 11, 1, 2, 3. It's out here. Sorry, folks. Okay, so we have this point, and this point. Okay, and we want to know this is where they all cross, which is at 7, 5, just like the last one. States coordinates, that's it. Okay? More talk about centroid and orthocenter, incenter, and circumcenter. So let's see. I have a feeling I know what these problems are about. So this is a centroid, which means these are medians. He measured CF and found it to be 6 inches. Look at this. Let's see. Let's go to centroid. The centroid divides the medians into a 2-to-1 ratio. Okay? That's really important. The piece of the median closest to the vertex is twice as long as the piece closest to the midpoint of the triangle side. You see that? 10, 5, 12, 6, 16, 8. So let's keep that in mind when we do this problem. So if this is x, then we know that this is twice that. So then we know that 2x plus x equals 6. Which equation can be used to find x? So this one. 2x plus x equals 6. And because we know that the whole thing, CF, is 6. So, and this has to be twice this, or this has to be half of this, which it is. That's it. And now the next few problems are probably going to all be just like that. Blah, blah, blah. They're medians. They intersect at a centroid. CF is the whole piece. What is the length of FG? Well, this is x, and this is 2x. So x plus 2x equals 24. 3x equals 24. X equals 8. We want FG, which is x. So FG equals x, which equals 8. 1. Medians and a centroid. The length of FG, this is 12. So then we know this is 24. So what is GC? Well, we just figured it out. It's 24. Right? The part closest to the vertex is always twice as long as the part that's touching the midpoint of the opposite side. Point P is a centroid, so these are all medians. PM is 2x plus 5, and BP is 7x plus 4. What is the length of PM? Well, BP equals 2 times PM, right? So 7x plus 4 equals 2 times 2x plus 5. 7x plus 4 equals 4x plus 10. Subtract 4x from both sides. Subtract 4 from both sides. 3x equals 6 divided by 3. X is 2. So PM is 2x plus 5, which is 2 times 2 plus 5, which is 4 plus 5, which is 9. Choice 1. Okay, BF is 18. So x and 2x, x plus 2x equals 18. 3x equals 18. Divide by 3, x is 6. What is the length of BP? BP is 2x, which is 2 times 6, which is 12. Choice 4. In the diagram below of TEM, they're medians, so this is a centroid, and TB is 9, so this is x, and this is 2x. We know that x plus 2x equals 9. 3x equals 9. Divide by 3. X equals 3. Find the length of TD. TD is 2x, which is 2 times 3, which is 6. Okay? So that's enough for tonight. Good luck.